Hello, welcome to our lesson on two-way tables. Today, we will explore some innovative methods that will enhance your understanding of probability and improve your problem-solving skills. In this lesson, we'll start to understand some new ways of writing out different scenarios so we can calculate probability. Our primary focus today will be on two-way tables. We'll begin by learning what a two-way table is and how it can be used to organize different scenarios in probability. Next, we'll explore how to fill in a two-way table with given data and interpret the information it holds. Finally, we'll apply this new knowledge to various examples and calculate probabilities from the data organized in the two-way table. In our previous lessons, we've built a solid foundation by discussing the following: probability notation, understanding how to represent probabilities using conventional symbols, the addition law, and sample spaces, where you list all possible outcomes of an experiment in a comprehensive manner. With this foundation, we can now introduce and make use of two-way tables. A two-way table is a pivotal tool in probability that allows us to organize data from two categorical variables and analyze their interactions. For instance, imagine we want to study the outcomes of rolling a die and flipping a coin. A two-way table helps us structure these scenarios clearly, enabling us to compute probabilities with greater ease and accuracy. Let's dive into understanding two-way tables. Two-way tables are a great way to organize data and visualize probabilities when dealing with two categorical variables. They allow us to see the frequency counts of different combinations of the categories. Let's consider an example where we record the grades of students from different demographics in a school. We'll categorize students by gender and record the grades they achieved. Here's a step-by-step guide to constructing the table. Step 1. Draw the table framework. Step 2. Fill in the counts of each category. Suppose we collected the following data. For boys, we got 8 A's, 10 B's, and 12 C's. And for girls, we got 15 A's, 18 B's, and 10 C's. Step 3. Calculate the totals for each row and column. For the rows, roaster boys' total is 8 plus 10 plus 12 equals 30. The total for girls is 15 plus 18 plus 10 equals 43. For the columns, A's total is 8 plus 15 equals 23. B's total is 10 plus 18 equals 28. And C's total is 12 plus 10 equals 22. Finally, we calculate the grand total. 30 plus 43 equals 73. Now that we have our table filled out, we can use it to find probabilities. For example, if we want to find the probability that a randomly selected student got an A, we can use the total number of A grades and divide it by the grand total number of students. Probability of A equals the total of A divided by the grand total, which equals to 23 over 73. Similarly, if we want to find the probability that a randomly selected student is a girl and got a B, we look at the intersection of the girls row and the B column. Probability of girl and B is girls B divided by grand total, which equals to 18 over 73. There are many benefits of two-way tables. Firstly, they provide a clear and comprehensive overview of data. Secondly, they allow easy calculation of both marginal and joint probabilities. And finally, they help us to quickly identify trends and relationships between the two categorical variables. By organizing and analyzing data with two-way tables, we can make more accurate predictions and better understand the probabilities of different outcomes. Let's start by looking at a simple example using a two-way table. Imagine we have a table that shows the distribution of students in a class by gender and whether they prefer cats or dogs. Here's the two-way table. From this table, we can answer several probability questions. Question 1. What is the probability of randomly selecting a girl who prefers cats? First, find the number of girls who prefer cats, which is 20. Then divide this by the total number of students, which is 50. The probability is 20 over 50, which equals to 0.4 or 40%. Question 2. What is the probability of randomly selecting a student who prefers dogs? First, look at the total number of students who prefer dogs, which is 20. Then divide this by the total number of students. The probability is 20 over 50, which equals to 0.4 or 40%. Question 3. What is the probability of randomly selecting a boy? First, find the total number of boys, which is 25. Then divide this by the total number of students. The probability is 25 over 50, which equals to 0.5 or 50%. Now let's move on to a slightly more complex example using another two-way table. This time, we'll look at the preferences of a group of people for different types of movies. Here's the table. Question 1. What is the total number of people surveyed? To find the total number surveyed, we need to add up the number of men and women. The total number of people is 60 plus 60, which equals to 120. You can fill the gap in the table with this result. Question 2. What is the probability of randomly selecting someone who prefers comedy movies? First, we need to find the total number of people who prefer comedy by adding up the number of men who prefer comedy and the number of women who prefer comedy. Total number of people who prefer comedy is 10 plus 30, which equals to 40. We can then fill the gap in the table. Then to find the probability, divide this by the total number of people. The probability equals to 40 over 120, which equals to a third, or approximately 33.33%. Question 3. What is the probability of randomly selecting a woman who prefers action movies? First, find the number of women who prefer action movies. This can be done by subtracting the number of men who prefer action movies from the total number of people who prefer action movies. The number of women who prefer action movies is 50 minus 30, which equals to 20. We can fill the gap in the table. Then to find the probability, divide this by the total number of people. The probability equals to 20 over 120, which equals to 1/6, or approximately 16.67%. By practicing these types of problems and using two-way tables effectively, you can get a clearer understanding of how to calculate different probabilities. This approach helps organize information and makes it easier to see relationships between different categories. Today we explored the concept of two-way tables, a useful tool for visualizing probabilities. We began by discussing how two-way tables organize data into a matrix format, making it easier to analyze the relationships between two categorical variables. We then examined how to construct a two-way table from a given set of data, ensuring that each cell represents the frequency of occurrences for the corresponding pair of categories. Next, we learned how to calculate probabilities from two-way tables. We also practiced interpreting two-way tables, identifying key patterns and relationships within the data. This included exercises on finding probabilities and expressing these as fractions, decimals, and percentages. By understanding how to effectively use two-way tables, we can simplify complex probability problems and gain deeper insights into the data's structure and relationships. Overall, mastering two-way tables equips us with a powerful method for organizing and analyzing probabilities, enhancing our ability to solve various statistical problems with greater ease and accuracy.